Okay, here's some examples where we got to combine those things. I talked about juggling these laws, and you've got to be able to do this. And I want to do these reasonably quickly because I'm hoping that you're like, yeah, I'm really with the program here. So here's what the question says. It says use exponent laws to evaluate each of the following on a separate page. You're already on a separate page. Yeah, you're ready to rock and roll on the separate page thing. So the idea is I look at the situation and I look and see what exponent laws can I use. And I think once you do a few of them, it'll be obvious which exponent laws to use in which situation. For instance, it helps to cover up part of the question. You just literally look and go, okay, I'm only going to look at the numerator. 4 to the power 3, 4 to the power 7. That's multiplication. When I multiply, what do I do with the two exponents? So the top becomes 4 to the power 10. Okay? That took care of the numerator. Now I go after the denominator, which is also multiply. And when you multiply, what do you do with the two exponents? Yeah, so I get 4 to the power 8. And you see how that's made a really complicated looking situation look pretty reasonable now. Now, I apply exponent law number 2, and I go, okay, it's divide now. And when I divide, what do I do with the two exponents? Subtract, and now I get 4 to the power 2. And we're not going to argue. We're going to discuss it all chapter. When should I leave it as an exponent, and when should I go to a number? And I'll say if the number's reasonable to write out. Yeah? Other years we sort of agreed on about 100,000. But again, there's no rule. You know, we'll just say, okay, well, what do you think here? Is 4 squared, which is 16, is that a reasonable number to write? Yeah, it really is. And so if they're sort of reasonable, just write them. When you get down to the final answer, write them as the actual number. Any questions about that first one? I got 5 to do, so if your brain's starting to hurt after, even with that little break in between, I've only got 4 more to go, like that. Questions there? More time? Do you see the juggling aspect of this now, where it's like, okay, I got to use this law, then I got to use that law? Yeah? You could have done this other ways, but this was the easiest way to do this one. Whoa, big numbers, ooh. See, the big numbers would be a big problem if we didn't have exponent laws available. The whole top of this thing, the whole numerator, is multiplying though. Negative 2 to the power of 100 times negative 2 to the power of 50 times negative 2 to the power of 12. So when it's all multiplying across the numerator like that, what can you do with all those exponents? You just add all these exponents. So the fact that there's 3 of them doesn't really change all that. So you might need your calculator, or you probably want your calculator in this particular situation, to add 150 and 12. Maybe not. 150 is 150, and 12 is 162. And the bottom is 159. Now it's division. When you have division, what can you do with the two exponents? And 162 minus 159 is so nicely 3. Isn't that convenient? And this is why we do these things, why we simplify them, because this horrific question that had all these big numbers in it actually turns out to be, its answer is negative 8. Right? And so that's one of the reasons why we do these simplifications, is we want to find out if we can make this an easier number to work with. And again, a reasonable sized number, so we do switch out of the exponent. If you punch it in your calculator and you get some giant number, just leave it as the exponent, that's no problem. And we sort of set 100,000 as our guideline. You know, it's sort of a guideline saying, well, it gets bigger than 100,000, maybe it's better as an exponent. But whatever. It really is whatever. You get to choose. Questions there? More time? Well, this is similar, only this is with variables now. You have to just switch over your brain and go, okay, I don't know what the number is, but I do know that in the top, it's all multiplying. And when it's multiplying, what can you do with the two exponents? I'm trying to be repetitive here. And you just add them together. So on the top, I get x to the power 10. On the bottom, I have x to the power 6. Now it's division. When it's division, what can you do with the two exponents? You subtract them, so now I go 10 minus 6 is 4. Okay, so the fact that the variables are in there, well, actually, I got to tell you, these exponent laws are really 4 variables. When it's just numbers, we practice with the numbers. So in this section, practice with the numbers. See, this thing, you could have just punched this in your calculator. I totally get it. But practice with the exponent laws with the numbers so that when you get to one with variables, you're ready to handle it. Do you have questions on number 2a? More time? Oh, okay, so this is where they start to get a little crazy, because this has x's and y's in it. And now I rewind to something I said. I tried to repeat it a couple times, but maybe I didn't make enough big deal enough about it. These exponent laws only work if the bases are the same. And here we got x's and y's. The x's and y's can't go together. X's can only go with x's. Fortunately, multiplication is very friendly. So instead of writing it as x to the power of 4 times y to the power of 3 times x to the power of 3 times y to the power of 5, I'm totally allowed to write it like this. And take a look at that to see that I haven't left anything out, that I wrote everything that was there before, but I've just moved it around on the top, which you're allowed to do with multiplication. Don't believe me? Listen to this one. What's 5 times 10? 50. What's 10 times 5? 50. Multiplication is very friendly. You can do it either way around, and that's what I've done here. Now I can use the exponent laws, but I'm just going to do a little highlighting action here. I can use the exponent laws just on that pair. Those things are multiplied together, so I can just add the exponents. And then I'll use another color highlighter here because I have it available to me. I'll use pink highlighter. Now I'm going to use the exponent laws on that pair. And I can add the exponents. And I think I've wrote this just right so you can see what's going to happen next. The x's and y's can't go together in the numerator. There's no exponent law that can put different bases together. But I could do this. I'll go back to my yellow highlighter. I could deal with those and deal with those. And you may want a highlighter or something like that, or just a pen to circle these as you're going through and going, oh, those are the same base. I can work with those. Those are the same base, so I can subtract. Those are the same base, so I can subtract. There's some management techniques when you get different variables in the same question. Any questions about how I set that up and managed it? Is anybody worried I broke some rules or something? You happy? More time? Last one. Maybe it's not big enough there, so I'll make it really big. Can you read it now? And this is the only one that incorporates the last of the exponent laws, so let me repeat it. When there's an exponent outside of brackets, which of the things that are being multiplied together get the exponent 5? All of them. So this negative 2/5, it gets exponent 5. This x gets exponent 5. And this y gets exponent 5. I'm going to try and write this just exactly right so that even though it's a big, hairy, scary mess, there should be a way to handle it. What should I do now? The numerator I can't do anything with because they're all different bases. The denominator I can't do anything with because they're all different bases. But what do you see in the numerator and the denominator? There's negative 2/5 to the power of 5 in the numerator. Is there any negative 2/5 in the denominator? Yeah, so this is where that highlighter thing comes in handy. I'm going to do 3 different highlighters. This, and this. I can use exponent laws on each of those. So here I get negative 2/5 to the exponent 2. Here I get x to the power of 5. I want to subtract. That one doesn't have an exponent. I want to subtract the exponents because it's division, but this x doesn't have an exponent. Now what? Yeah, whenever those things don't have exponents, you can always give them 1. That trick might seem pretty familiar because we did that with denominators last chapter, right? Doesn't change its value. So now I can subtract. And there's one last step here. Now that we're down to the end, we can evaluate this number. Each of these numbers gets squared. So I get a 4 on the top and a 25 on the bottom. Those are reasonable numbers, so I think it's worth doing to apply those exponents when they're reasonable numbers. The number set came out to 6 million over 2 billion, then maybe you wouldn't have applied the exponents. But here, 4 over 25, that's a nice little jump there. Any questions there? Okay, so here's the plan. You've got another break at 2 o'clock. Yes? 2 to 2:05. You've now got 45 minutes to attack that first round of homework, page 89. It will go pretty fast, I think, for the first part. The first 4 or 5 questions, I think, go really fast. If you happen to finish page 89, you could go back to 72. It's not needed. You could even just read through page 72 and check out those questions. If all that's done before 2 o'clock, you could take a look at page 96, but I think you might find it pretty difficult until I teach about it. I intend to teach about that at 2:05 after your break. Question? Okay. I'll go check it out. It'll depend on how long my last lesson takes, because I'm going to teach at 2:05. I don't know how close to the bell I'll get, so I'll try.